0.32. Sorry, minus, because it's the opposite direction. Okay, minus by 0.4, minus by 2487. Okay, so this will be, so the answer will be the same, right? So 6217 times by 0.6 minus by 6632 minus 0.4 minus 2487 multiplied by 0.2 is equal to 6217 minus 0.6 minus 6632 multiplied by 0.4 minus 2487 minus 0.2, 580. Okay. Again, some rounding error. Okay, because I round off some figure. Okay, so it's the same. Okay, you decide which direction. So now when you have all this, the last one is the torque. Okay, so the last one will be the torque. So where we are now, we have my, mz. Next, we want to find the torque. Okay, so the torque. Now the torque, you have to draw a torque diagram. Okay, so torque. So we know the torque is in the x direction, right? The torque is all applied in the x direction. So we have calculated the torque already. So what do I mean that we have calculated torque? So we have point A. Now this is where a lot of students get really confused with the torque. Okay, so this is point A, this is point C, this is point D, this is point E, and this is point B. Right? Again, our transformation X, Y, and this is our Z. So based on the motor rotation, right? We know based on the motor rotation, right? The input, right, is at point E. And point E we calculated to be what? From the top, from the motor. Then let me go back, okay? From the top of the motor, we calculate to be 596.8. Okay, so 596.8. So this is 596.8. And point C and point D will resist, yes or no? Right? It will resist, so it will be going on in the opposite direction. Right? Because our force is in that direction, okay? Multiplied by radius, so it's the resistance, right? So we calculated this also. So we have at point C is 379.9. 397.9. And then the other one is 198.9. So 198.9. Okay, right. Okay, so there's, now we're going to draw the torque. Okay, so as I said, the torque is the one that a lot of students make a lot of mistake. Okay, I don't want you to make the same mistake. So now we have our point A. So this is our torque. Now this is critical. Okay, don't make mistake. This is the part that is so important. So this is torque in the x direction, or yeah, torque in the x direction. Now it's a function of x. So point A, point C, point D, point E, and this is our point B, right? So A to C, from A to C we have nothing. Okay, so it's 0. Okay, so this is 0. Right? C to D we have 3798. Okay, so 3798. So now this is equal to 397.9. Okay, so the height from here to here is 379.9. Then it has C to D, it will flat line. Now D will be 198.9. Now this 198.9 is a cumulative. Okay, so it goes up. Okay, so it goes up. Right? So when it goes up, right, the distance from here to here is 198.9, but the value, so 397.9 plus 198.9 is equal to 596.8. Newton meter. And then at point E, it goes in the reverse direction. Yes or no? It goes in the reverse direction, so now it comes down to 0. Right? Because the direction is 0 and then it comes back here. Right? So now it comes back down here. So it comes back by 596.8. Are we clear? Okay, this is how you draw it. Okay, a lot of time again, student make a lot of mistake on this and I get so upset. Okay, so from here, we're going to compile everything. Okay, so we're going to compile position. So we have point A, point C, point D, point E, and point B. Okay, give me another 10 minutes. Okay, I'll be done. I know you all cannot wait to get out. Okay, so you have torque in the X direction, moment in the Y, and then moment in the Z, right? So let's look at torque in the X first. So this is 0, right? Then C, you have 397.9. And then D, at point D, you take the highest one, okay? You get 596.8. Right, 596.8. And point E, I know point E you share with 0 and the highest value, take the highest value. And point B, you have 0. Then you look at moment in the X, in the Y direction. So I'm going to take the moment in the Y. All right, I'm going to take this whole diagram. So I no need to come back here and there, right? So we're going to look at moment in your Y. So that's why I say don't worry about the positive and negative, because when you square it, we'll be fine, right? So at point A, a moment in Y is equal to 0. Moment at C is 1243.4. At point D is 1160.4. At point E is 580. And then 0 again. Okay. And then you take moment about Z. Okay. So we're going to look at moment about Z. So our moment about Z. Okay. So point A is again 0. Right. Point C is 186.4. Point D is 372.8. Then you have 559.2. And then you have 0. Okay. So what we are trying to do over here, okay, we are going to find, okay, we're going to find, why we tabulate, we want to find what is our maximum. Okay, so we want to find what is our tx squared plus by my squared plus by mz squared. We want to locate the what? The maximum. Because it's where the maximum your structure will what? Will fail. Okay, so the next one we're going to compile everything, or we're going to add everything up, or find the maximum of square root my squared mx squared plus mz squared. So we know that this is 0, this is 0. So it's 397.9 squared plus by 1243.4 squared plus by 186.4 squared then you square root. So you get 1318.8, right? So 596.8 squared plus by 1160.4 squared plus by 372.8 squared, square root 1357. Okay, 1357. And then the last one, which we already know will not be the largest value, plus by 559.2 squared is equal to 1002.6. So we know that failure will occur at D. Right? Because it has the largest tx squared plus by my squared plus by mz. So the formula that we're going to use now, okay, so it's J over C, polar moment of area of the shaft over C is equal to tx squared plus by my squared plus by mz squared, and then we have located the maximum, and then you're going to divide by the stress allowable. Okay, so this will be equal to 1357. The stress allowable over here is equal to, what was it? 50. Okay, 50 times 10 power 6. Okay, so 1357 over here, right? So 1357 divided by 50 power 6 is equal to 27.14 times 10 to power minus 6. Okay, and this will be in meter cube. Okay, so now we know that J will be equal to pi over 2 multiplied by C to the power 4, where C is the radius of the shaft, right? So now from here, so J over C, so pi over 2, C to the power 4 divided by C. So this will be equal to pi over 2 C cubed, and this will be equal to 27.14 times 10 to the power minus 6. So C cubed is equal to 2 divided by pi multiplied by 27.14 times by 10 to the power minus 6. And finally, C, so 2 times by 27.14 power minus 6 divided by shift pi equal to, so answer power by 1/3. So it's equal to, wait, I got something wrong. 27.14 power minus 6 times by 2 divided by shift pi equal to, okay, and then cube root of my answer is equal to 25.852 times by 10 to the power minus 3 meter. So the question is asking for diameter. So the minimum diameter is equal to twice times by 25.852 10 to the power minus 3. So it's equal to 51.704 times 10 to the power minus 3 meters. So it's about 52 millimeters. Okay. So that's all I have now. Okay. So this is how, okay, we design the shaft. Okay. I know it's a pretty long procedure. The most important thing is how to break down your, so what we learned quickly, I'll summarize. Okay. So what we have learned is, I think among all, what is the most critical is this direction. Okay. You got those direction wrong, your moment will be wrong, your torque will be wrong, everything will just go wrong. Okay. And then how to break down your torque. Okay. And then how to calculate the reaction. From the reaction, how to calculate your moments. So all these are all taking moments. Then from your moment, how to analyze your torque. Okay, so from here you get the diameter of your shaft, and it's dependent on your shear stress, because we use what? We are using our shear stress, maximum allowable shear stress. Okay, so you'll see a lot of this type of problem. Okay, so in 3A, this is the only time you see shaft, but when you go to 3E, you can see it very often. Okay, so do not forget how to do this. Okay, other than that, that's all I have for today. Anyone, any questions, please? Anyone? I hope you're still alive. Okay, if not, I'll see you guys on Thursday. Now, Thursday, there's lecture. Okay, this Thursday, there's lecture. Okay, if that's the case, I'll see you guys next week then. Thank you for your time.